Suppose I wanted to move one of these disks. How could I do it? And obviously that's one way of doing it. But there is another way. I've got them on a piece of stretchy rubber. So the second way of doing it is simply to stretch the rubber. And it's the movement of the rubber itself which carries the disk along with it. Now, this, in fact, is a very good analogy for the expansion of the universe. These galaxies here are not so much moving through space as being carried along by an expanding space. In fact, galaxies take part in both kinds of motion. If you're thinking about how the galaxy moves within its local group or cluster, moving around the other galaxies, then that is motion through space, the normal kind of motion. But if you're thinking about a couple of clusters of galaxies and why they are separating due to the Hubble expansion, then that movement is due to the expansion of the space between them. If you're thinking about a very distant galaxy or cluster of galaxies, then that kind of motion due to the expansion of space becomes the dominant motion. Now, it's very important to get the distinction clear between those two types of motion, because this sort of motion, where you're thinking about motion through space, that is governed by Einstein's special theory of relativity. And as you've probably heard, one of the requirements of that is that nothing can travel faster than the speed of light. But if you're thinking about the other kind of motion due to the expansion of space, then special relativity has nothing at all to say about that. And therefore, there's no reason why speed should not exceed the speed of light. In fact, if you're thinking about a galaxy which is so far away it's beyond the horizon of the observable universe, then sure enough, they can indeed be moving faster than the speed of light. Right, now, this is actually quite a good analogy in as much as not all distances here expand. As I stretch the rubber, the disks themselves obviously don't change in size. And that is also the case with the galaxies. Although the space is expanding, the galaxies themselves do not change in size. And that's because they, like the disk, are a bound system. In that case, what you've got is gravitational forces holding the stars together. And that not only holds the galaxy together, but it keeps it the same size. So it's only the distances between galaxies that change. Actually, of course, it's pretty obvious that you can't have all distances changing, otherwise you wouldn't actually know that anything had happened. If you have a distance which it doubles in size, but I measure that with a ruler which also doubles in size, you get the same answer. So you can't have all distances changing. There's one way in which this is not a good analogy, and that is, of course, that the rubber sheet has got edges to it. And as far as we know, three-dimensional space does not have an edge or a boundary to it. It just carries on. Also, this sheet has got a central point, which I think would be somewhere like there. Now, why do I say that? Well, I'm judging it as being equidistant between the two edges. But as I say, with three-dimensional space, if there's no edge, then I've got no place from which to judge where the center might be, the center of the universe. So any point in space is as good or as bad as any.